Welcome. Very happy to be here with you. Probably it's going to be the last time that I talk at VMware, so it has a very special meaning for me. And I'm a networking and security specialist with VMware. I've been here since 2012. I've been a customer, a partner, a systems engineer, and then a specialist. And I do this, so it's not, I don't have any marketing slides. Sorry if that was the intention. This is the wrong session, so I'm not going to be offended if you said I don't want to be here and you walk away. But everything is GA, so therefore you can use all the features that I'm going to talk about, and you probably have been using, hopefully, a few of them already. So everything is GA. You can use it. This disclaimer, I still have to put it in, but doesn't apply because hopefully we'll determine that most of the things are useful and are available today. So again, if this was a session about futures, this is not the session. Everything is GA here. This is the agenda right away. We are going to talk about the virtual switch access layer. In networking, we have three layers. We have the access layer, right? We have the aggregation and core, or a collapsed aggregation core, access layer, or if you're using layer 3, leaf and spine, which, you know, the leaf will still be the physical access layer. So we're going to talk in the first part of our agenda about the virtual switch access layer. In VMware, or every time you do virtualization, there is a virtual access layer. So we're going to talk about the virtual access layer in VMware that is delivered via the virtual standard switch and the virtual distributed switch. The differences between the two, and then we're going to move into how we can extend networking services for that virtual switch access layer. In other words, how we are going to make that virtual switch access layer more interesting, if you want. And we are going to include NSX in it, which is our networking and security platform. So the first part is native vSphere. The second part of our talk, which is the reason why we're here, is how NSX can extend the virtual switch access layer networking services. And we're going to finish by connecting that virtual switch access layer to the physical layer. In between, I'll give you troubleshooting tools, so that way we are 100% aligned to the description of the presentation, which, being a customer, having been an attendee, I love when the presentation that I go to is 100% aligned to the description, okay? So I also try to do it that way. We're going to start right away. If you remember one slide, I spent enough time here to give you in one slide a quick overview of all the networking features and functionality that you will find in the virtual switch access layer. This is natively. This is mainly virtual distributed switch, but some of them are in the virtual standard switch. Couple of things is, you may think, oh, VMware is not a networking company. You know, we have only been doing networking since 2013 with NSX. And as you can see, I put the dates too. So I went back and mapped it out. So you can see that we had features in there way back. Especially if you take a look at the introduction of virtual distributed switch, it was May 2009. Okay? So when you think about all the feature and functionality, let me tell you why my customers use the most, and then you can compare notes with what you use the most, okay? So, as I told you, this is practical. Jumbo frames. Everybody that I know in my customer base, every time that have implemented this, one way or another, they have enabled jumbo frames. That's one of the features. Another one that is pretty popular lately is IPFix NetFlow. Right? For flow, information exchange, flow monitoring, right? So IPFix is another feature that I've seen in the last couple of years being used a lot. The port mirroring, sometimes for troubleshooting, We support port mirroring and the different types of port mirroring. Well, I have one slide for that one. That is another one that is used a lot. Obviously, lately, when we introduce Network I/O Control version 3, Network I/O Control version 3 will help you enable a fair chance of the different types of traffic to access the underlying infrastructure, right? So that one is one that I recommend you to at least enable, and then you can explore how to use it. Don't do it in prod first. Obviously, enable, play with it, and then put it in production. But if you enable it by default in prod, it's safe. But don't change the reservation right away. Just get used to it first. And the last two that I would say are being used in the last couple of years a lot are the multiple TCP/IP stacks. And we added in 6.5 last year the default gateway per VM kernel interface card. So one thing is it's not the same multiple TCP/IP stacks and having a default gateway per VM kernel NIC. It's not the same. It's two different things. One is two different stacks, and the second one is in order for you not to have to create a new stack, but give it that kernel interface a default gateway that is different than the default TCP/IP stack gateway. I told you it was going to be technical, so it's right away. I'm not wasting time. If you don't follow me, just ask me the question. We enable that gateway per VNIC, which is a very useful feature. So out of all the things that are there, those are the ones that I would just say, if you remember just one slide, go to this slide when they make it available and just pick and choose the things that are most useful for you. Okay, so when you create a virtual machine, the virtual machine is going to have different components, right? X amount of memory, CPU, disk, and among other things, it's going to have a virtual Ethernet adapter, a virtual network interface card. In a physical adapter, we have something that is called the BIA, the burn-in address, the MAC address that the adapter comes in. The VMX file of a virtual machine has the MAC address of that virtual Ethernet adapter. That virtual Ethernet adapter MAC address is very important. So I'm talking about this right here. So we create a VM, we load the operating system loads a driver, the driver sees an Ethernet card, the Ethernet card has a MAC address. And now we obviously get an IP, either because we manually configure it or we got it through the HCP, and now we can send and receive, okay? Before we can send and receive, that network interface card is going to be connected to a virtual switch access port. And that virtual switch access port is not in there, but I'm going to tell you, has a couple of security features right away, right? You probably remember some of them. Promiscuous mode, for example, right? MAC address change, forge, transmits. And all those three things that the virtual switch access port security features has is going to compare the MAC address in the VMX file to the MAC address that the OS is trying to present. And it's going to say, it is the same, or you try to change it. And it's going to check the port security, okay? Little tidbits, but right away, security is top of mind when you connect that virtual network interface card. Now we have a port, and port, like in physical switches, are part of the port groups, okay? And the port groups in the virtual standard switch or the virtual distributed switch are very important entities because they create an abstraction layer too. So the port groups usually, what do you do with them? You tag them, right? You tag them, and they are VLAN-backed port groups. VLAN-backed port groups, okay? So we have the VNIC connects to the virtual switch access port. The virtual switch access port is part of the port group. The port group is tagged with, obviously, an 802.1q tag, which is a 12-bit identifier that gives me from 0 or no tag to 4094, okay? So we support three types of tagging: virtual guest tagging, virtual switch tagging, and external switch tagging. The external switch tagging, the physical infrastructure is going to tag it. We are not going to touch it anything. Virtual guest tagging, the guest is going to tag it. And the most common one, the one that you do, is virtual switch tag, which is the virtual switch port group is the one that is going to carry the tag. Okay? So we have VNICs, virtual switch access port groups that have the tag, and then we have the physical adapters. Those are the PNICs, the physical network interface card. Okay? In the GUI, that is represented by the VMNIC, not the VNIC, the VMNIC. So the VMNIC is the physical adapter. Okay? And that is going to be the uplink to the physical world. Did you see the title? Single host. Because the virtual standard switch boundary is the single host. Okay, so the next question is, what happens when we have two hosts? Well, what happens when we have two hosts is that, unfortunately, we have two virtual switches. And it's a pain in the neck. Okay, why? Well, because we need to configure every port group with the label, with the VLAN tag. We need to make sure that we trunk everything to that second and third and fourth, etc., host, and that they need to match. Right? So that is the boundary. The boundary is the host. So if we have two hosts, we have two virtual standard switches, which is in a way a challenge when you have more than 2, 3 hosts. Okay? So remember, the boundary of the virtual standard switch is the host itself. The VMNICs are the physical uplinks to the physical switch. Now, what about this thing that we always talk around, management plane and data plane? Have you heard that lately in the last 4 or 5 years? People started talking about management plane and data plane, management plane and data plane. The virtual standard switch management and data plane is self-contained. Okay? The virtual standard switch, it's configured either through the host client or it's configured through the web client. And that way, you configure the switch itself. The boundary is the host. So management plane and data plane, which is the forwarding, is self-contained. Nothing more, nothing less. One thing that is the last thing that I'm going to say, it is going to help us build the next part of the conversation, is that we have a special type of interface, which is not a virtual NIC. It's called the VM kernel network interface card. Okay? So the VM kernel network interface card is an adapter for the host to provide services. Okay? So the adapter lets you provide services like management, vMotion, vSAN, virtual extensible local area network, VXLAN as well. It lets you provide services to the VMs like iSCSI, NFS, provisioning. So I'm telling you all the different types of traffic because that way you understand why the VM kernel network interface cards are so important. Okay? So virtual standard switch, the boundaries, the different types of components in it, and one is services to the VMs, and the other ones are the VMs connected to the virtual switch access layer. Well, we now want to break that boundary. We want to go beyond the single host. So here we have the virtual distributed switch. The virtual distributed switch creates a data center representation of that object. In other words, now I can go to my management plane and say, I want a switch that extends across this X number of hosts. And now this X number of hosts are going to participate or are going to be part of that virtual distributed switch. When I create, as the operator in my management plane, I create a port group, Now that port group is instantiated across all of the hosts participating in that virtual distributed switch. So anybody can tell me what is the boundary of the virtual distributed switch? Just if you know, it's OK. And what do you mean by that?
The data center and the vCenter.
The data center object?
Yes.
Very good. The data center object is the boundary of the virtual distributed switch. The data center, you know, when you right-click, create new data center, and only then you will see the option to create a virtual distributed switch. So that's the boundary. And that is the maximum boundary. But can you do it per cluster? Absolutely. You can do it per cluster. You can do it per host. Just the boundary object is the data center. Very good, by the way. Excellent. OK, so when I create another port group, it's going to be instantiated across all the hosts. So now, instead of having port groups, we have distributed virtual switch port group. OK, DV port group. So port group, DV port group. That was easy, right? App links are a little bit different. App links are not the same as physical NICs. Just small detail, but important one. And I can tell you more if you want to know more. The distributed virtual switch app link port group is a new concept in virtual distributed switch. The distributed switch port group here, what it does is it lets you define app links, but those app links are objects. And those objects are later associated with network interfaces cards, like the physical network interface card. So don't confuse app links with physical NICs, OK? It's not the same. They are related, but they are different objects. And we will see why this is important. Now, what about, yeah, I get it, this was good. OK, what about the management plane and the data plane? Well, now we have decoupled the management plane from the data plane. And this is what we see here. At a vCenter server level, we see the virtual distributed switch. And that is my management plane. That is where I go and I create my virtual distributed switches. OK? But then there is a hidden switch inside the host that is called the host proxy switch. The host proxy switch is a local switch to that host that contains the configuration that that host should have. OK? This is something that not too many people pay attention. It is in the documentation, by the way, but unless you get the context for it, you don't know what it is. So it's a hidden switch that is provisioned right inside the host, and it contains all the configuration. OK, why is this important? Because what happens when you don't have vCenter server, right? Does it mean that this is not going to work anymore? No. We have a local object already provisioned and configured. So the management plane is good for configuring, the data plane is good for doing the forwarding, and the configuration is also inside that host proxy switch. OK? So a couple of new things. Distributed virtual switch uplink port group, where I determine the number of uplinks, and the number of uplinks are associated with the physical NICs, and separation from management plane and data plane, plus hidden local switch, which is the host proxy switch. We're good? Is the pace good enough? OK. You got to tell me. OK. So I have a challenge here. These slides, as a presenter, they always tell you, don't put slides like this. But this is a reference. Don't worry, I don't want you to memorize. Now, I do have a special prize, because that slide is incomplete. So I have a pretty cool, at least I think it's cool, right? My wife thinks that the things I do are not cool, so don't worry. I think this is a cool prize. It's something that they gave us, the VMware employees. So there is something missing in the list of things that the distributed switch can do compared to the virtual standard switch. If somebody knows about it, I will be more than happy, because I don't want to bring this back. right? So I'll give you a minute. Take a minute. It's not that hard, and I'll give you another clue. I already mentioned that feature. Oh, now I have a problem. Who said NIOC? Okay, you got it. Thank you very much. Network I/O control. Yes, it was not a tricky question. I gave you the answer at the beginning, but you had to look at it. So network I/O control is not here, and it's a pity because it's a very important feature. Use it as a reference to see what the two switches can do. By the way, because I cannot, believe it or not, it's very bright here. Can you clap if you're still using the virtual standard switch? Nobody's using the virtual standard switch? Okay. That's very helpful. Can you clap if you're using the virtual distributed switch? Okay. Pretty good. I was hoping that to come in 40 minutes or so, but thank you. Okay, cool. So there is one more thing because before I go into the troubleshooting. What are the tools for troubleshooting? We added the cross vSwitch vMotion. I don't know if you are aware of this. We kind of launch things sometimes, and we launch so many new things. This is a practical, good thing. Doesn't cost anything more than just right-click and select the source and the destination virtual switch. But you can say, you know what, Gabriel, we already had this. We already had the VSS to VDS migration. So what is the big deal with the cross vSwitch vMotion? It's not a migration. You can still migrate from a virtual standard switch to a virtual distributed switch. You can migrate. You know, we have the wizard that will migrate the VMs and that will migrate the VM kernel ports for you. This is live vMotion. Well, there's no such thing as live vMotion. If it is vMotion, it's live. I always get my hands slapped by engineering. There's no live vMotion. Yes, vMotion, okay? So you can vMotion between switches, between a VSS to a VSS, a VDS to a VDS, and obviously between a VSS to a VDS. Very useful. The only reason why I put it in there is because my customers do use it. So if you didn't have the chance to use it, this is something that is being used in the field. Okay, now we go into some of the tools for visibility and troubleshooting. For visibility and troubleshooting, we have Cisco Discovery Protocol, Link Layer Discovery Protocol. Those are pretty useful. I think that everybody uses them. IPFix, look, people use IPFix. They have started using IPFix lately. We leverage IPFix, among other things, when we ask you to do a virtual network assessment with Network Insight, which is a very, very useful tools in the toolbox that we have. So IPFix is being used. Port mirroring, if you have the networking team that is asking you to do, you know, span or ER span or remote switch port analyzer, another feature that is very useful. Network health check, it's not for you to enable all the time, but if you're going to make a change, you can enable it, make the change, see if everything is okay, and then disable it. It's pretty useful, right? Some people don't like to leave it running all the time because it will send layer 2 echo probes, and you know, some networking teams don't like that. But if you enable it, do the changes, make sure that the VLAN NTU, the terminate failover are good, then you can disable it. So pretty useful too. And you know, if you're really trying to do RCA or root cause analysis, packet capture -user world, it's a tool that is at the ESXi host level that lets you do packet capture in the different filters that we have in the I/O path. So this is something that in the physical world you could not do. In the virtual world, you can capture at different points, different stages in the I/O change, which is the input-output change between the virtual network interface card and obviously the virtual switch access port through the uplinks, et cetera, et cetera. And you can export that to Wireshark, for example, if you wanted to. Good slide for reference if somebody challenges you or tells you, oh, I lose visibility, I don't have this, I don't have that. You know, you have a slide now, you can send them, say, hey, you know, take a look at that slide, tell me what you want me to enable. Fair enough? Cool. So, not too bad. In 20-something minutes, we went from one host to multiple hosts. And now the challenge is, how do we go beyond multiple hosts and beyond multiple virtual distributed switches? So that is the challenge, right? So that is what we're going to do next. We are going to go from one host with the VDS to multiple hosts, right, a data center level object, to multiple virtual distributed switches. You're still with me? Let's go. We can't wait too much time. So with the last slide is the perfect slide for introducing NSX, and this requires NSX. We are exiting the native vSphere virtual distributed switch, and we are entering NSX. So enter NSX. And you will be thinking, he had to put a slide with all those icons, and it's like, I'm going to make it easy. Don't worry. I have to put it because you need to have the context for it, right? We talk about the management plane, and we talk about data plane so far. But we never talk about control plane because we didn't have it until NSX when we started NSX in 2013. So NSX is nothing new now. So the data plane is where the forwarding happens. And this is what we are going to focus the rest of the talk, or the second part of the talk. Only this little service here, which is called the distributed logical switch, or logical switch if you want to abbreviate that. Logical switching, only that. I'm not going to cover anything else. VDS plus the logical switch with VXLAN. Still, we're following the description of the chat, of the talk. So we added the controllers. The controllers gives us information about, ARP, IP addresses, MAC addresses. And instead of having to use broadcast, unknown unicast, right, which unknown unicast ends up being broadcast at the end of the day, we talk unicast with the controllers. And the controllers gives us the state of the network. Think about, the network is very dynamic, changes every time. VMs be motion from one physical port, behind one physical port to another, behind another physical port. We need to track the changes. We need to have convergence. What if we could just ask the information that we needed? And that is the role of the controllers. So the data plane was there. The virtual distributed switch enabled with NSX will give me that logical switching element that is going to allow me to extend beyond virtual distributed switches. The controllers are going to suppress the amount of broadcast and unknown unicast and obviously multicast as well in the network. And then the management plane, still the management plane, where I do the configuration. Okay? So let's go into it. Why are we doing this? Because every time that you want to provision a new VLAN, what do you have to do on the virtual distributed switch? You got to make sure that that VLAN is also provisioned in the physical layer. Okay? So if you have a layer 3 leaf and spine, it will end at the top of the rack. If you have an aggregation, right, core, aggregation core, collapse aggregation core, and an access layer, you got to make sure that the layer 2 is end-to-end. And you got to make sure that you properly trunk all the VLANs to the host. And you got to make sure that you tag those distributed switch port groups as well. So there is a dependency there. We have been doing this for, quite a few years now. But there are also layer 2 end-to-end limitations or challenges, if you want. Some of those challenges are, the larger the layer 2 domain it is, the higher the chances of problems. As one of my colleagues would say, local problems, global consequences, sometimes, with a big layer 2. So another way of saying it is that, switch when you must, route when you can. Okay? What did we do about this? How we can decouple the physical underlying transport network from the service that we want to provide, the logical switching service. So we still want to provide switching, layer 2 switching, but we don't have to reconfigure the physical network every time, okay? So the industry agreed on this standard, virtual extensible local area network. Instead of VLAN, we added VXLAN. So virtual local area network, virtual extensible local area network. And what we do is we use, obviously, UDP and IP to encapsulate the original layer 2 frame, and then with basic connectivity, without having to change anything, without having to reconfigure the network, we create an encapsulation between two tunnel endpoints, or TEPs, tunnel endpoints, okay? And every time that you do encapsulation, what do you have? What do you need? A header. You need a header. Pretty good. So in the header, we have the VXLAN network identifier, so the VNI. The VXLAN network identifier, think a little bit like the VLAN ID, 12 bits, 0 to 4094, but the VXLAN is not 12 bits. How many bits? 24 bits, so double that. So we can have 16 million plus of VXLAN virtual network identifiers. This slide, I included it because I think it's important for you to understand that the original Ethernet frame is not changed. It's not different than it was. The only thing that we are doing, we are adding a VXLAN header. That header will have, in the first 8 bits, is going to have a flag that is going to be called I. I know it's maybe hard to read, but believe me, there is an I there. It says RRR, which is reserved, reserved, reserved. I, which is the ID of the virtual network identifiers, which is that like VLAN ID, okay? And then there is an L, I can tell you what that L is, and then the RR is the other 2 reserved bits. Then UDP, source port, destination port is always the standard VXLAN port. And then the outer IP header, the IP header is the original IP? No. It's the IP of the tunnel endpoint, the source and the destination, okay? And the same thing for the MAC. Make sense? So we take the original layer 2 frame, we put a VXLAN header, we put an ID to know which VXLAN logical switch we want to go to. We say this is the source, which is a hash of the inner layer 2, layer 3, layer 4. It's good for entropy. It's good for spreading the traffic across multiple paths, if you have multiple paths. And then we go to the destination port, which is always a well-known port for VXLAN. And then we add the source IP and the destination IP of the tunnel endpoints, VXLAN tunnel endpoints, and then the MAC addresses. Okay? No, so that is the reason why we go from 1,500 bytes to 1,600 bytes. It's not 1,600 bytes, but you need to leave room for the future. So the question was, I'll repeat it because they are recording, is that, will the original MTU change? And yes, the answer is obviously. That is why now you know why it changes, because if you add, 14, 20, and 16, it's going to give you the 50 bytes. But we asked for 1,600 just in case you're using, for example, IPv6 inside the original layer 2 frame, right? But now you have the slide. You don't have to chase it. So it may be too much detail, but if you read inside every one of them, there are good nuggets of information there. Okay, so let's see how this works with our VDS. So far, so good. We understand the VXLAN will allow us to, use the physical fabric, 1,600 bytes. So that's why at the beginning I said jumbo frames is something that is used very much because people already have it. So everything starts coming together now. And we have created through the management plane a logical switch. Remember the VMware kernel interface that I told you provides services to the VMs? In this case, the VM kernel interface that is going to do the encapsulation and decapsulation of that VXLAN logical switch is the interface or interfaces that are going to provide the service. Don't worry about it. I have an animated slide just coming after this one. Remember the concept that the virtual distributed switch is the foundation. We're going to create a logical switch in it, and then that logical switch is going to use a service from the host that is going to be the VXLAN tunnel endpoint. And obviously, the destination host is going to also have another VXLAN tunnel endpoint. You still with me? OK, let's do this. So we created a logical switch A. VM1 is attached to that logical switch. VM2 is attached to that logical switch, but it's on a different host. And now we have a layer 2 or layer 3 fabric. Doesn't matter. It doesn't matter if it is layer 2. It doesn't matter if it is, leaf and spine. It doesn't matter. Yes, there needs to be connectivity between the two hosts. Like I need to be able to reach the other host. Okay. So now I said, oh, well, I want to send something from VM1 to VM2. Walk me through how do I do that without having to reconfigure my physical network. OK, let's do it. So I want to send a layer 2 frame from VM1 to VM2. It's going to go from the logical switch, distributed port group, to the VM kernel interface of the host that is going to provide the VXLAN tunnel endpoint service, so the encapsulation and decapsulation. So it goes for the VM, nothing has changed. I send it to the destination host. The host will provide the service of encapsulating that original layer 2 frame, and is going to use the fabric to deliver it to the destination. The destination tunnel endpoint is going to decapsulate the frame, so the VTEP removes the additional header, and now it is delivered. It wasn't too bad. I told you that if we can get all the pieces together, it's not too bad to understand. OK, what happens if I create another logical switch? Do I need to recreate something on the physical network? No. That is the whole idea. It doesn't matter how many I create. Doesn't matter. I can create another one. I need to communicate with logical switch B, the VXLAN tunnel endpoint, or the VTEP, that is a VM kernel interface on the host, is going to do the encapsulation. It's going to deliver it to the destination IP. If I can reach the destination, I'm good. It's going to decapsulate that, and it's going to deliver the layer 2 frame. Make sense? I'll pause for a second. How are we doing? Any questions so far? We're good? OK. Good? I'll go quickly through this one. Bottom line is, whether you have layer 2 or whether you have leaf and spine, doesn't matter. As long as you can have connectivity between the tunnel endpoints, you will be able to create the encapsulation without having to reconfigure the physical network. We covered this, so this is fine. Tools. We want tools. OK, so now we are talking about not only virtual distributed switch tools. We are talking about visibility into the VXLAN. We still have all the tools for the virtual distributed switch at the vSphere level. But NSX, besides being pretty cool, gives you additional tools. So the dashboard is new. The dashboard is going to tell you about the health and the status of the control plane, the management plane. And it's also going to tell you about the status, the warnings for the logical switches. So you don't need to do anything. It's new. It came in 6.3 like 6 months ago, something like that, with the first version. I think it was January 17 for the 6.30. So it's been around for a while. This is new. And the dashboard, as you can see, has some spaces because we keep adding to the dashboard. We keep adding capabilities, OK? And then we have, obviously, syslog. I'm going to skip through that one because you know that. Then we have the VXLAN ping through the GUI that is going to test for you the MTU between the tunnel endpoints. Fair enough? So this is all GUI so far. Then if you don't like the GUI, or you want to have options, you have the VXLAN BMK ping, and here you need to specify the NET stack, the TCP IP stack. Remember at the beginning, I told you that we use TCP IP stacks? There is a new feature that we introduced. Okay, so you specify the stack, and now you can do the same VXLAN ping from the GUI through the VMK ping. We have live flow, we have flow monitoring, endpoint monitoring, and I save the best for last, which is trace flow. Trace flow, that is the demo that I wanted to do. Trace flow is gonna inject a synthetic packet in the IO chain. It's gonna coordinate between the tunnel endpoints, or between the two endpoints, or the two VNICs, more specifically between the two VNICs, right? It's going to have to go through the tunnel endpoint, but it's more specifically between the two VNICs. What is cool is it's going to tell you about the firewall rules as well. It's going to tell you if it was dropped. And what is new in 6.3, we're also going to tell you if you have redirection, because we can do service insertion and service redirection. It's also going to tell you that it's going through, for example, one of the partners, Palo Alto Networks. Tools, troubleshooting tools. So now we went from single host to multiple hosts to multiple VDSs, not having to reconfigure the physical network. We check the native tools. We check the tools for VXLAN. We review why VXLAN is a standard and encapsulation protocol that adds a header. The header has no mystery. You know exactly what header. And by using a service, which is the VXLAN tunnel endpoint, provided through the VM kernel network interface card on the host, we can create encapsulation and decapsulation and abstract the underlying physical network. Now, all good, all virtual so far. Let's talk about the last part of our presentation and our session, how we are going to connect this to the physical world. Okay, let's do it. So, general recommendations. You know, these are recommendations in general, but you don't connect the physical, host to only one physical switch. You usually connect it to two different physical switches. No mystery there. The second thing is that, in general, we could say that everybody has two 10 gigs at least. Clap, please, if you have two 10 gigs so I can. If you don't have two 10 gigs, what do you have? Because not everybody clapped. You still have two 1 gigs? Or multiple 1 gigs? Some? No? 210, we can agree? More than 210? You have 6 1 gig? Okay. Okay, and depends on the server. Okay, so that makes sense, why not everybody clapped, so that's good. And then, how do we configure the physical access layer? Well, you know that the virtual distributed switch, or for that matter, the virtual standard switch, don't participate in spanning tree protocol, okay? We cannot create a loop because we don't bridge between two network interface cards, okay? So we don't participate, and it's safe to configure port fast or port fast, for example, if you obviously want to avoid going through all the phases in the spanning tree protocol. But in general, it will be like an edge port or like an edge trunk port, right? Obviously. So that is safe to configure. And for the ones that are doing, for example, a service provider, it is OK to configure BPDU filter. So we can also do BPDU filter in case a VM is compromised at the virtual distributed switch layer, OK? Just as a reference. This is an advanced feature in the ESXi host. So you can configure that. BPDU filter in case, because you know what will happen. If you configure BPDU guard on the physical switch and then the VM starts sending, bridge protocol data units, the access port is going to shut it down. The virtual distributed switch is going to move it to the other surviving uplink. It's going to start sending BPDUs. The physical access layer is going to shut it down again. So the BPDU filter, if you're really in multi-tenant environment, will stop it at the virtual distributed switch layer. So we are covered, right? All the possibilities are covered. OK, really quickly through this one, we all know that 210 doesn't mean 20 gigs. And by that I mean that just because you have 210 doesn't mean that you have 20 gigs. You could have best case be using the 20 gigs. But this is never the case, okay? So how can we not only provide redundancy because we connected to two switches, but also make sure that on top of the redundancy, we take advantage of the bandwidth as much as we can of those two uplinks. Make sense? So we're going to see what do we do in traditional VLAN-backed port groups. No VXLAN so far. So far we are connecting our virtual switch or virtual distributed switch to the physical layer. So what are the options? The first option that you're going to see is explicit failover. Explicit failover means that you are going to dedicate one network interface card to be the one connected, the active one for that uplink, and the other one is not going to be used. It's going to be in standby mode. So you lose 50% if you want to. What are the advantages of this? It's very predictable, right? And you don't have overcommitment. In case you lose one, you always will have maximum the 10 gigs that you always had. If you need to provide SLA and people say, no, I don't want to have contention even when you lose a physical NIC, this is a good option. It's an option, right? What is the granularity level? Well, the granularity level is at the port group, because the port group, per port group, you can configure the load balancing or how to spread the load between port groups. So granularity, port group. Okay, are there more options? Yes, the default option. This is the default option because it's the safest option. It is the option that most of the cases is going to work well all the time. And now the granularity changes from the port group to the port ID, where the virtual network interface card is connected to. From port group to port ID. And what it's going to do is going to try to ensure that for every network interface card that the VM has, there is only one uplink that is selected. So it's going to do, depending on the number of uplinks, it's going to do 1, 2, 1, 2, 1. It's going to try to use the port ID as a way of spreading the traffic. So we go from port group to port ID per virtual network interface card. The third one is LACP, Link Aggregation Control Protocol. And in particular, I'm talking about dynamic LACP, okay? 802.3 AD. So now the granularity goes to the flow. So we went from port group to port ID to flow. And per flow, we are going to pin it to one specific uplink. Make sense? So, per flow. Which one is best? It depends. We're going to see the pros and cons. Okay, so let's do it. Now, we mix that up with VXLAN because we want to take advantage of the VXLAN. So we want to know how the decision that we are going to make around the uplink connectivity is going to affect my VXLAN. So, if we use explicit failover, the benefit is obviously it's very simple to configure. No dependency on the physical network infrastructure. One active, one standby. Not too much to say about it. No requirements from the physical fabric. And the load distribution, there is no load distribution. Always goes through the active one. Now, did you, let me go back. How many VTEPs? 1. How many VTEPs here? 2. Why? Because if you have 2 physical interface cards and you choose the originating virtual port ID mechanism for spreading your traffic, NSX is going to create one VM kernel network interface card per each network interface card that is physical. Why? Because it's going to map it one-to-one. So you could potentially start using 2 VXLAN tunnel endpoint to encapsulate and decapsulate. So this is very important. This is key. Because every virtual machine is going to try to send, and it's going to be through one uplink or the other, okay? Now, the challenge is that, well, you need a little bit more IPs, because every VM kernel interface will have an IP. So instead of having one IP per host, now if you have 2 uplinks, you will need 2 IPs per host. I know, it's an implementation detail, but plan for it, because the number of hosts is going to grow. So if you grow by 20 hosts, it's not just 20 IPs that you're going to need to be free. You are going to need 40 if you had 2, okay? Benefits is it's pretty good load distribution. It's not load balancing. It's a load distribution mechanism. It's pretty good. It's not perfect, but if you have more VMs, it's going to do a very good job. If the consolidation ratio goes higher, very, very good load distribution. The other benefits is, like, from a physical networking point of view, no configuration required, okay? And the last one that I promised you was the LACP, dynamic LACP. In this case, if you use LACP, you're going to create a LAG, a link aggregation group, okay? So now the granularity is going to be higher. But how many VXLAN tunnel endpoints are you going to have? Why? Exactly. Very good answer. It always will see the link aggregation group is one group. So for all intent and purposes, I only have one. How the link aggregation group deals with the hashing per flow, not a problem. It's from a kernel interface, I have one interface, right? So the challenge is, now I'm going to configure one to one switch, another one to another switch. So you need things like VPC, ESCO, or multi-chassis link aggregation, which you may think, oh yeah, easy peasy, I can do that. I don't know. Yeah, it's your network, but be careful. It's not a straightforward answer, okay? Can I use it? Yes, it's pretty good. The flow is pretty granular. The dependency is that the physical network needs to be configured for the lag to be created, okay? And now the very first thing that we tried to do was to have to reconfigure the network every time, right? So you're going back to, weighting pros and cons. Make sense? Which one is the best? It's up to you, okay? Last slide. I wanted you to have a summary of this. So if you choose route based on originating virtual port ID, it is supported by NSX with VXLAN? Yes, absolutely it is supported. It supports multi-BTEP, VXLAN tunnel endpoints? Yes. What is the advantage of having a multi-BTEP approach? Is that, when it comes to CPU and memory reservation for that VM kernel interface, you're going to have it. So because you have 2 now. So your load is spread across the 2. So this is a good one. And it's the default. And it doesn't require the physical switches to be reconfigured for it. Okay? And what is the behavior of the uplinks? Both uplinks are active. And the granularity is per port group. Okay? Actually, per virtual port, depending on how many virtual network interface card is going to be connected to a virtual port. And that is the granularity. Now, what about LACP? LACP only supports one VXLAN tunnel endpoint. It is supported by NSX, and both are active, and it's flow-based. You have 23 different algorithms, 20-something, 23, I think. Pretty good, but now you need to configure your physical network for it. And the last one is explicit failover order. Only one uplink is active. OK, I'm going to pause. And we still have a few minutes, so we can open it up for questions. How are we doing? Absolutely. That's what.
VXLAN header?
Oh.
Because I can't find any reference to it.
Okay, I can tell you the answer. Okay, so would it be okay if I go back? It's painful, but if I don't go, it's no way I can explain it without the slide. So the question, just for the recording, is what is the L bit?
Yep.
I hope I don't get in trouble for this, but okay. So we have the VXLAN header. The VXLAN header has the flags, and we said that some of them are reserved. The I is for a valid ID identifier, and the L means replicate locally. So when you have, replicate locally, that's, I don't know if you're going to find references for this, but you came here, so you got it. So the replicate locally is because we support 3 different types of replication in VXLAN. Unicast, which is the default, multicast, which is the original VXLAN replication mode, and hybrid. When you have hybrid mode, we take the best of the unicast and the best of the multicast. And the L bit in the packet, in the VXLAN header, tells the VXLAN endpoint that is not local on that layer 2 segment. The remote VXLAN tunnel endpoint tells it replicate locally. So instead of us having to send to remote networks 100 queries saying, okay, where is this VM? We send it only once, and we tell in the L bit to a designated remote VXLAN tunnel endpoint, you are in charge of replicating locally. When he does the replication, he clears the bit. And now it's a regular packet.
Okay, thanks.
I know.
Yeah, that's cool.
They grilled us when we have to learn these things. So
that's good.
Yeah.
All
and
right.
the other question?
Yeah, so
there were 2.
the other question is, what's the best way, or the easiest or the quickest way to make sure that if you have a problem, that it's not because you've misconfigured the extent of your VDS versus your transport zones?
Yeah, so he's talking about transport zone, and transport zone is the boundary for VXLAN logical switch, because we talk about the boundary for the VSS, we talk about the boundary for the VDS, but we didn't talk about the boundary for the logical switch. So the transport zone is the boundary for the transport zone, for the logical switch inside the transport zone. So the best way of doing that is making sure that you are preparing the VDSs in the clusters that have the hosts, right? And you got to make sure that you don't misalign the VDS.
I just don't know if you have a trick or some way of.
You gotta check it out, because you're gonna see it, because the distributed logical router at layer 3 is not gonna let you add it.
Okay. Yeah. I'm sorry. I did have a third question.
Thank you very much. We can still stay for questions, but I wanted to thank you very much. Hey.